So this takes about, 15 minutes. So we can train the full ResNet like a couple hundred times. It's more than enough for us to finish the project. I mean, you can try it 5 or 6 times. So okay. So and then what we're gonna do is we click edit. But you will see copy and edit, as something like this. Okay. So click edit. So here is, you can add your own data, okay. But the idea is you shouldn't add any models. So this will be seen in the starter code. And you can submit to the competition, and the most important thing is notebook options. So for example, you want to choose this P100, okay? So for example, this notebook used 18 minutes out of 30 hours, and it resets on Friday. So we have how many resets? But anyway, so just do this P100. Okay. And in order to demonstrate, let me run this. Okay, run this out to start. So let's run this out. Okay. So user warning, a non-par version is greater n. Oh, really? Okay. Let me change. I mean, so this is just a warning, so it's not like code breaking. Still has this warning. Okay, so for example, this is our directory. So if we put, how do I make this monospace font bigger? Is it possible? Anyway, so you can see this exclamation mark here. So this, if you play with Linux, this basically invoke the possibility of of using a Linux command. For example, this is ls to show like what's happening in this directory, which is input. And so this is our input directory. So we put it here, and so we load the data. Oh, wait. What's happening? Oh, okay. Sorry. So if I do this, I click this, it runs only thing that's highlighted. Okay. So don't do that. And then we have, okay, so the same thing. I mean, everything is the same. So visualizing, we can skip visualizing. So we'll do the same for the optimizer, okay? So for example, we can try, so IMS prop. You can try BFGS, okay? But the BFGS is very, very complicated to implement. So this is like a baby version of gradient, not baby version, but a variant of gradient descent. So that only changes a little with gradient descent. Okay. So what you can do is, okay, so everything is the same. So here is the same, here is the same. Yeah, maybe I should change this to touching pro. Let me change this to touching pro. Down and we do this. Pip is invoking this, like Linux interface again. If we have an exclamation mark. Okay, so it's down, and let's try this. And now we have a model summary. So this is our parameterized model. So everything so far is the same. And okay, everything so far is the same. But so now this is different. Okay. So all I'm gonna do is so this function, this train test split, okay. Oh, it doesn't have collab option. Anyway, so this train test split is from scikit-learn, so sklearn, model selection, train test split. Okay. So basically what happens is, oh, it didn't have a diagram? Okay. But anyway, so the idea is we split the data matrix into two parts. The one is called train, the other is called test. So for here, it's rather called validation, okay? So what's happening is, originally we have a big matrix. Okay, so for example, right here, okay. So originally, we have the shape of trained data is 40,000 and 28 by 28, which means we have 40,000 samples, and each sample is a 28 by 28 matrix, okay. So what's happening is train test split this matrix, this tensor, this 40,000 samples into two parts. So for example, we chose. So if this train size is 0.8, it just means, like I commented here, so 80% of the data is being used to train the model. So 20% during training the model won't see is reserved to validate this model to check if its performance is acceptable in the data set it has never seen. Okay. Yeah, like I said earlier, so we set the random state in machine learning experiment because we want our experiment replicable and the other one can reproduce our result. This is a very good habit. If we set a random state, basically this is just random number generator seed, and because the random number are not really random, it's pseudo random number. It's deterministic, but it satisfies the distribution. So I won't go into detail here. And so this part is the same, but we have now two set of data. One set is we call the train set, the other we call the validation set. Okay, and we put it into the pipeline of this data loader. We load, so we run the code. So once it's run, we can use this next iter, this command, to make it as an iterator, and we get the sample. So we have the same sample. Okay, let's check. So this is also a good habit. That is, we check if we can go through the models, but with this width, torsionogram means we don't register all the gradient for each parameters. So as we can see, if it go through, then it's good. So now it's we write our own optimizer. So here it's slightly different if we compare the two code. So for example, if we compare the code from previous one. Okay, so previous one is pretty simple. It's just to follow this optimizer interface. First, we have this constructor, and then we implement this step, this function. Okay. So, so all these are templates. So the only formula we use is this. This is like the next iteration equals. So this is the next iteration equals itself, which calls the previous iteration subtract this step size times the gradient. Okay. So here is we implement what we called Nestrov momentum, which I'll give the formula. Yeah, I should have given the formula here. So this is the formula right here. Okay. So basically, this is a formula. And then return the loss. So the template is the same. And for the final project, the minimum requirement is we translate.
Can I see the formula again?
Yeah, you will see it. You can.
I mean, in the class we have practiced the formula is related to our theory class.
No.
Oh.
So so here the idea of the training is given a formula.
Mm-hmm.
So look at this formula. Given a new formula, you should be able to translate this formula into PyTorch code by yourself. Okay.
Yes.
So without the help of anything you have learned. So the ability you learn this class is to learn new things, so without your instructor's help. So this is this is also beneficial for your future research if you plan to do a PhD, So is to learn, the ability to learn new things. So for example, we should be able to translate this formula using what we have learned. So for example, how to compute the L2 norm of a vector, okay, to Python. All right. If you don't know how to do it, you can come to my office hour. I can show you step by step. So, okay. And then the rest is the same until this part, okay? So this part is also a template to check the accuracy in the validation set. So let's go through the code again. Okay. So for example, so we just call this this one. So for example, what you want to do is you want to set a momentum to be some numbers and Nestor to be true. So now we just do the training. So for example, here the code is exactly the same with previous. So this one, this template, this is like a template. We don't have to change anything. It's the same here, okay? So first, we send this to GPU, and then we do a forward pass, we plug into the loss function, and this is, we record the loss function's value, which is our target function. And here we clear the gradient from last iteration, and we do back. This is just taking gradient using chain rule. So back, CS people has a fancy name. This is just doing gradient using chain rule, okay? And this is then taking the gradient descent. So it's the same here. Everything is the same, except after we take the gradient descent, okay, there is an extra, this validation step to check how our model performs in our validation set that this model has not seen, okay? So for example, here, so here is also, another trick is if the model's training doesn't improve in the validation set, then we stop the training. Okay. So, and then the rest is the same. And this is the template. So once we have, you can save, for example, you can save. So if I stop this, stop session, we can save this. You can either save and run or do quick save. So if we do quick save, so what quick save does is basically, because notebook we can view the output immediately, unlike a compiled language. And now we can simply view. So this is not run, okay? As we can see, it only takes 6.5 seconds to run. So the code doesn't run, but instead it just saves the output. And we can check. We can even, for example, right now this is version 2 now. If we click this 2 of 2, we can go back to version, for example, version 1. Okay. Is this already? Oh, this is already version 1. Great. How do I view it? Okay, all right. So for this version, we have an output because I run it. Okay. for example, we have this my solution. We can basically click submit, okay? And so this is like a class demonstration. So for example, this is submitted, you know. It's getting this much, you know, score, okay? So so once we submitted, we can view its score here, okay? So yeah, so basically that's it. That's it for our final project. So now I'll take questions. Okay. Okay. So if no question, I'll stay here. The rest of today's class is just office hour, so you can ask whatever you want. That's it. If you don't have question, you can go. And for those of you who haven't got the papers back,
Cheyenne Khan.
how do you spell?
SHA.
Yeah.
What is the condition? So what is the sufficient condition for the to be positive definite? Yeah, but you need to show it. Why? What's your name? No, I cannot. Oh, okay.